really quick intro/review on right triangle trig. I think we're pretty good at this. We could use a little practice. So here's one question that kind of question you could be asked. Express y and z in terms of trig functions of theta, or trigonometric ratios, they sometimes say, like in the section we're talking about. Okay, so the idea, and we'll talk about this in a second, the idea is that you're actually going to be given theta in a problem, and you'd be interested in how tall something is, or how long a string is, or a diagonal, or a ladder, or something. And we just want to get in terms of the general formula. So suppose we know this is fixed to be 120, and you're about to give us theta. We want a general formula that's going to pop that out real quick. Okay, so that's not hard. We just look at what ratios. We always compare the known quantity to what we care about. So in one case, it's going to be y over 120. That's opposite over adjacent, and that's going to be tan theta. And so solving, we get y equals 120 tan theta. And that's the kind of thing we usually get, is the side we want is another side times a trig function of theta. And then z over 120, that is, let's see, hypotenuse over adjacent. Well, we could, if we memorize that, we could memorize that that's equal to secant theta. And then it's easy. It's 120 secant theta. If we haven't memorized all 6 trig functions, you should definitely have sine, cosine, and tangent memorized. Suppose we didn't have that memorized, and we just knew cosine. Hey, I know adjacent and hypotenuse. That has to do with cosine. We could just say 120 over z is cosine theta. Okay. And then either flip both sides to get this guy, or cross multiply. Let's just fit it in over here. 120 is z cosine theta. Divide, and you get z equals 120 over cosine theta. Oh, hey, that's this guy. Okay. So anyway you slice it, we get z is 120 secant theta, and y is 120 tan theta. So here's an example of that. Oh, looking for my eraser. It's right here. Let's say we are out at we're out in the out at sea, and we're just offshore, or we're fairly close, of Dubai. So we're in the Persian Gulf, really. And Dubai is where they have the tallest building in the world as of a few years ago. I'm not going to try and do justice to it, but it's kind of like a pointy, and then it's kind of got these sort of cylindrical things coming off. And this is called the Burj, which means tower. Khalifa, which means the guy who bailed them out after they built it and didn't have any money left over. And it's a beautiful building, and it's super tall. It is 828 meters tall. That is unbelievably tall. Okay, suppose we're in a ship. Here's a little boat, and we look up, essentially from sea level, which is essentially the bottom of the Burj Khalifa, and we look up, and we can measure this angle. And so this is called, because it's measured up from a horizontal, it's called an angle of elevation, and they mention this in the book. It's good to look in there as well. And we calculate it. We notice that the top of the Burj is, let's say, 2.3 degrees. Can you tell I just made that up? I just made that up. But that's a plausible kind of angle of elevation. And we'd like to know, how far are we from the base of the thing? We'd like to know. Didn't even leave any room for it. Oh, right here. What is x? What is the horizontal distance? We could also try to get the diagonal distance, but it's kind of more reasonable to get the horizontal distance. How far do we have to sail until we're right at the bottom, right? If we could sail right to the bottom. You can sail to within pretty close to it because it's right on the sea, right on the shore. Okay, so what is x? Okay, well, we know theta. We know one of the angles in a right triangle. That's a right triangle because this is actually a straight up and down tower. It'd be super impressive if it were a leaning tower, 828 meters, but it's not. Okay, so we just have to do exactly what we did before. Okay, we've got x over 828 meters. Ooh, what is that? That's adjacent over opposite. That's cotangent. Okay, so x is going to be 828 meters times cotangent theta. Okay, and we know the theta, and so in fact x is going to be 828. And you know what? Most calculators don't actually directly do cotangent, so it's really going to be, you're going to do it as dividing by tangent of 2.3 degrees. And yeah, guess what? We have to change back into degree mode. I'm all about radians most of the time, but for geometry problems, we really do want degrees. And so what I'm going to do is I'm just going to go ahead and bring up this, and so we're just going to take 828 divided by tangent of 2.3 degrees. So make sure you're in the right mode, or you're going to get a horribly incorrect answer. And let's see if this can... So, and what units is that in? Remember, the 828 was in meters, so this is 20,615 meters, or in other words, 20.615 kilometers. And you know what? I only gave you 2 sig figs, so at best it's probably about 20.6 is a good answer for kilometers. Okay.